Very good morning, guys. Today we have one aim. The aim is that how we can develop an algorithm for the Newton divided difference interpolation formula. Second, our aim is how to develop Matlab code for the Newton divided difference interpolation formula. In the previous lecture, in the previous Matlab practical class, we have developed one algorithms. We have developed one Matlab code where we can construct a divided difference table. The program was here. Just look the program we had here. In the previous lecture, we had the program how we can form the divided difference table. First, we have to input the value of x in the form of vector form. Then we have to input y in the form of vector form. Okay. Now we have measured the length of x, means the number of data point. Now we had constructed null matrix A. Then we insert the value of x as a first column of the null matrix and second column of the null matrix. So we had ultimately these matrices. And we did the for loop algorithm here, how we can get the first divided difference column in the divided difference table. From the 4 column onwards, this was the algorithm that we have developed in the previous practical class. Those who are getting difficulties, or those who had absent, or those who are not seeing my video of the divided difference construction table, please look the video in the previous lecture what I had developed algorithms and developed Matlab code for the divided difference table. Let us try to run this one we had in the previous class here. Thus input the value of x in vector form. I have input here. Input is here now. Look the input. This is 4, 5, 7, 10, 11, and 13. Input the value of y. Thus input here 48, 100, 294, 900, 1210, 2028. Enter it. If I do the enter here, I can get one 4-word table here. Right. It is the divided difference table. This is upper triangular form. Right. This is upper triangular form. So this was the table I have formed here. This is the value of x. This is the value of y. This is the column number 3 where the first divided difference operation was done. This is the column number 4 onwards. We have developed an algorithm and we have developed an Matlab code where we can get this is matrix 1, 2, 3, 1, 2, 3, 4, 5, 6. 6 number of row and 7 number of column. This column will be the last here. So this was the Matlab coding. This was the Matlab coding we had developed in the previous lecture. Now today, what is our aim? Our aim is that we have to develop an algorithm how we can find our the interpolating value by using the divided difference table with the help of Newton divided difference interpolation formula. See, this table we had constructed in the previous lab session where we developed an algorithm how the value of this delta cross y1, delta cross y2, delta square cross y1, delta cross y0, delta square cross y0, delta cube cross y0, how they are calculated, we have already discussed in the previous lab session. That's why those who are absent in the previous class or those who are not looking my video, please go back in the previous lab session. I have already uploaded in my channel regarding this construction of the divided difference table. Today our aim is that we want to use this divided difference table in the case of Newton forward, means Newton divided difference interpolation formula. Today our aim is that, what is our aim? We have two aims today. First aim is that to develop an algorithm for Newton divided difference interpolation formula. In the short form, it is written as Newton divided difference interpolations formula. This is our aim number one. Okay. Our aim number two is that to develop Matlab code for Newton divided difference interpolations formula. So we have to develop first algorithm, then we have to develop the Matlab code. Okay, this is our two aim today we have here. In the previous lecture session, we have already constructed the table. This was the table we have constructed in the previous class. Okay. Now, first aim. What is the formula for us? We need to understand Newton divided difference interpolations formula. What was the expressions? The formula was like this: f of x is equal to y naught plus x minus x naught, right? Delta cross y naught plus x minus x naught, x minus x1 delta cross square y naught plus x minus x naught, okay, x minus x1 into x minus x2 delta cross cube y naught, and dot dot up to n number of terms. If I go up to this, into x minus x n minus 1 delta cross n y naught. This is the theoretical formula for the Newton divided difference interpolations formula. Okay. Now it has been observed that the value of this can be obtained from the table. The value of this can be obtained from the table. The value of this can be obtained from the table, and value of this can be obtained from the table. What is the table here? Look here. The value of delta cross y naught can be estimated from the table. Okay. The value of delta square cross y naught can be estimated from the table. Same thing here. Delta cross cube y naught can be estimated from the table. It means that it is taking from the matrix location where it is the first row, and column is moving from here k is equal to 3 onwards. Okay, so I need to take the value of this, I need to take the value of this, I need to take the value of this from the table. It is from the first row and column 3 onwards. Be careful, right? From the first row and column 3 onwards, the value of delta cross y naught, the value of delta square cross y naught, the value of delta cross cube y naught can be calculated for the Newton divided difference interpolation formula. Just look this formula, right? So this red circle, this red circle, this red circle, the values can be taken from the our divided difference table. In the previous lectures, we have already constructed the table. From the table, it has been observed that the red circle values are estimated from the divided difference table, where it is the first row and third column onwards. Okay, let us try to develop an algorithm how we can calculate the value of y for particular value of x with the help of Newton divided difference interpolation formula. Before doing that, let us try to classify here in the two parts. One part is suppose this part, right? Coefficient of delta cross y naught, coefficient of delta cross square y naught, coefficient of delta cross cube y naught. Same thing here, coefficient of delta cross y to the power n. Okay, for example, suppose this variable I want to define by z. I want to define this variable by z. Okay, again, let us try to define what is z. This is the coefficient of delta cross y naught. Okay, delta square cross y naught, delta cross cube y naught, delta cross to the power n y naught. It is defined by our. Let us define another variable. This is the variable, right? This is the variable delta cross y naught. Let us define this is by small a. This is defined by small a. These values are defined by small a. Means we are trying to classify all these things in two parts, right? One part is that z, suppose variable k, right? Suppose this is taken x minus x naught, okay? X minus x1, it is gone up to x minus x n minus 1. This is one variable we have defined here, okay? Second variable I have defined, suppose ak is equal to, what is this? This is delta cross y naught, right? Delta square cross y naught. These are the variable which is coming from the table. It will come from the table. It will come from the table. Now let us try to define another variable ck. Suppose this is the product of zk and ak. Why it is? Look here. Ultimately, if I get the value of z, if I get the value of a, I have to multiply it. Suppose this is c1, this is c2, c3, c4, c5. It means I have to first find out this value which is defined by z. Okay, I have to find out all this value which is defined by z. I have to find out the value of this which is defined by z. I have to find out this value which is defined by z. And what is a? A is the variable where it take the value of this from the table. And ck is the multiplication of ak and zk. Why it is? In the formula of Newton divided difference interpolation formula, it has been observed that x minus x naught is multiplied by delta cross y naught. X minus x naught into x minus x1 is multiplied by delta square cross y naught. So let us define z, a, and c. Here, this is the first term. This is first term, right? This is first term. This is second term. And this is third term onwards. Now, if we observe here, first term and second terms, they have huge difference in the formula. But second terms onwards, the formula is some trend line. They are following some trend line. Therefore, I have to do some differenting for the first term. In the first term, for the first term of this first term of Newton divided difference interpolation formula. What is my observation? The first term is here, y naught is the first term. In the formula, y naught is the first term. Okay, how can I get this y? Suppose z1, suppose k is equal to 1 is equal to 1. Okay, and c1 is equal to suppose y, right? Suppose this is the y. That value I have inserted for you. Value of y. What is the value of y? I will take from the table. Value of y means I will take the first value. I will take the first value. Okay. So first means y1. So I'll take the value of this in the y1. Okay. So I'll take the first value y1. Okay. It means that c is equal to c1 is equal to y1. It means it will give the first value of y. Means from the table I can get the value of y naught. I can get y naught here, right? I can get here y naught. I can get here y naught. This is the logic behind for the first term. For the first term, I have this logic. Now, second terms onward. Second terms onwards. Second terms onwards of Newton divided difference interpolations formula. What is the second terms onward it is working? It is very interesting to discuss second terms onwards. How I can define now z? It is very much important for us. How can I define second terms onwards? For example, if I want to define zk, okay, if I want to define zk is equal to, suppose it is x minus x naught x minus x1 dot dot, suppose x minus xn minus 1. This is the in general term. Now, how it can be estimated, it is very important. It is very important case are here. How I can estimate all these things are here. Now let us try to write this is in the form of, suppose zk. K represent here number of terms. Zk, can I write it is like this: x minus the x locations which is in k minus 1. Okay, this is term, multiply here z k minus 1. Can I write this one? Can I write in this form? Can I write in this form? Let us try to cross check here. How can I get these terms can be implemented in this form? What is the meaning of this? The value of zk can be estimated if the value of zk minus 1 is given, right? If I have the value of zk minus 1 is given, then the value of zk can be calculated. It means that z2 can be calculated if I have zk is equal to 1. Z3 can be calculated if I have Z2. For example here, let us try to explain here. For example, if k is moved from 4 to n plus 2, suppose k move, the initial value is 4 and maximum it can take, suppose n plus 2. What happened in that case? Let us try to write this equation number 1 in this example. How it can be? For k is equal to 4, let us try to cross-check how it can be estimated. It means that equation number A implies that Z4 is equal to x minus x3 into this is Z3. It means that if the value of Z3 is estimated, I can find out the value of Z4. Now, if the value of K is moving from 2 onwards, let us try to cross check here. Now, let us try to not 4 here. Suppose it is start from 2. Suppose it is started from 2. What happened here? If it is started from 2, means I can put here, if K is equal to 2, then what happened? Equation number A implies that Z2 is equal to x minus x1 into Z1. Okay, what is Z1? We have defined for first Z1 is here 1. It means that the Z2 is equal to x minus x1 into 1. I put the value of Z1. Now, this is the value of Z2. This is the value of Z2. Let us try to define K is equal to 3, what it can be, right? Now, equation number A can be implies, suppose Z3 is equal to, just put in equation number A, I can get here in equation number 3, I can get x minus x2 into Z2. Yes. Now put the value of Z2 here. Now putting the value of Z2, I can get here Z3 is equal to x minus x1 into x minus x2. Okay, I can get, I just put the value of Z2 here. I have just put it the value of Z2, I put the value of Z2 here. So I can get, this is the value of Z3. Now come here, put the value of Z3 now. So I can get, it is x minus x3, x minus x1, x minus, this is, I can get. Now this is the value of Z4. This is the value of Z4. Similarly, from equation number A, a Z5 can be calculated now. How can I calculate? X minus x1, okay, x minus x2, x minus x3, x minus x3, and x minus x4. So it can be calculated. So now, if I look the formula here in the Newton divided difference interpolations, look here. I have defined this is by Z. I have defined this is by Z. I have defined this is by Z, and exactly I got. Don't confuse here x0 and x1. We are talking I is moving from 1 to n. I represent the number of rows. Okay, so here x0 may be x1. Why it is? Because we move from row number 1, not row number 0. It means that I have developed an algorithm for the coefficient of delta cross y0, delta cross square y0, delta cross cube y0. So I have developed an algorithm. So finally, we have developed an algorithm. Finally, we have develop an algorithm for ZK. We have developed an algorithm for ZK. Okay, we have developed an algorithm for ZK. What is the algorithm we have developed here? We have developed here for the first term, right? For the first term, be careful here. For the first term, in case of Newton divided difference interpolation formula, first term we have another algorithm. Now, be careful here. For the first term, it was y0. Okay, algorithm is coming here. What is the algorithm? We have developed z1 is equal to 1. Okay, we have developed c1 is equal to y1. So y1 means first row, right? For the second terms onwards, right? Second terms onwards. Second term onwards of Newton divided difference interpolation formula. Okay, we have developed one algorithm. The algorithm is like this. The ZK can be written in this form, right? X minus X, right? K minus 1 multiply Z here, K minus 1. This is the algorithm we have developed. Okay, so we have developed one algorithm for the coefficient Z, right? And we have developed an algorithm for the first term of the Newton divided difference interpolations. Now, interestingly, let us try to expand this one. How it can be here, right? In terms of for loop, how we can write this is in terms of for loop. Okay, now be careful here. Be careful. Those who were absent in my previous lecture session, they should look my videos of the last class. Look here. In the case of divided difference table, we have column number 1, column number 2, column number 3, column number 4, and column number 5. In the column number 1, there is no any operations because this is the value of x. In the column number 2, there is no any operations because we are taking the value of y directly from the column number 2. It means there is no any operations. Okay, in column number 3, if we look at my previous lecture session, you can see that the algorithms we have developed, the algorithm we have developed for k is equal to 3 is not exactly same whatever we have developed for the k is equal to 4. So the algorithm of k is equal to 3 and k is equal to 4 is different. Means k is equal to 4 onwards, we have developed an algorithm where we can get the divided difference table. It means that I am trying to move from k is equal to 4 onwards in my calculations for z. Okay, I want to move from k is equal to 4 in my case of calculations. Now, how it is coming here? Just look here. From k is equal to 4 onwards, I want to move. That's why our algorithm has to be developed in such a way that, see, the k is equal to 4, right? It moved from k is equal to 4. For loop, I want to write the for loop. I want to write the for loop here. For loop, right? K is equal to 4 onwards. And we have explained very clearly in the previous session of the development of algorithm for the divided difference table. It was moved from n plus 2 up to n plus 2. Now it means that from second terms onwards, if I want to apply the looping system from k is moving from 4 to this, I need to rewrite this like this. See now, I have the value of z1, right? Then only I can get the value of z2. I have the value of c1, then only I can get the c2. That means now I have to write this is z, right? It should be now instead of k, I will get here I will get k minus 2. Why? If I put the value of k is equal to 4, what I can get? I can get z2. Now z2 can be calculated because the value of z1 is given here. And why k is moving 4? As we discussed in the previous session, the divided difference table operation is taking place from column number 4 onwards. Okay, they are directly linked with the divided difference table as well as with the Newton forward divided difference interpolations. Without that divided difference table, we are not able to find out our we cannot estimate our interpolating value. Why it is k minus 2? Because k is equal to 4. If I put here k is equal to 4, I can get z2. Z2 can be calculated because I have here z1 from the first term. Okay, so now algorithm is like this. Zk minus 2 is equal to, for example, instead of x, I put it here p. What is the p? This is the value of x, right? Here x is equal to p means this is called the interpolating point. Means if x is equal to p, I want to find out the interpolation value. It means that x k minus 3. Why it is k minus 3? Because if I put here k is equal to 4, I can get here x1. What is the x1? X1 is, this is the fourth row, right? It is coming x and y like this. This is x0, x1, x2, y0, y1, y2 like this. So this is the first value I can get. This is the second value and this is the third value. Now this is the value I have to input from the keyboard. So x minus, right? The value of x is, I have put it here p. K minus 3, right? Because k is equal to 4 here, so I can get here x1. Multiply. Thus it is the extension function of this one. Okay. Z here, this is k minus 3. Why it is k minus 3? Because if I put k is equal to 4, I can get z1. Then z1 value can be estimated from here. Okay, so I can get here like this. Now this is the algorithm we have developed, that how we can get the value of z. Now put the value of k is equal to 4, 5, 6, 7, 4 onwards. So I can get the value of z2, z3, z4, z5, z6, z7. What are the z's? What are the z's? Z's are the this, right? What are the z's? Z's are the coefficient of this. If I put z is equal to 4, I can get this. If I put z is equal to 5, I can get these terms. Z is equal to 6, I can get this term. Z is equal to 7, I can get this term. So I have estimated now coefficient of delta cross y naught, coefficient of delta cross square y naught, coefficient of delta cross cube y naught. These are estimated from our algorithm. And algorithm was designed according to this discussion, right? Zk, suppose this So I can rewrite this is in this format, and I have discussed here if k is equal to 2, k is equal to 4, k is equal to 3, how it can be calculated. So finally, we have developed the algorithm like this. Second term onward, this is our algorithms. But in our case, k is equal to 4. Why it is in the divided difference table? The operations were taking place mainly from k is equal to 4 onwards here. Okay. Now come up here. Let us try to define our a. Now let us try to define our a. AK. Okay. AK. What was the a? A was the value of delta cross y naught. See, I had defined delta cross y naught as a, right? Delta cross square y naught as a, delta cross cube y naught as a. These are the a we have defined. Now, how it can calculate it? How it can be calculated? It is very simple now. Now, AK, this AK is defined the matrix A from the first row and the column number. From where I want to take the column number? Column number I want to take k is equal to 1 onwards. Why it is? Because our for loop here, our for loop is trying to move from k is equal to 4. If k is equal to 4, I can get here A is the matrix where I can take the first row and third column onwards. It means that I have to find out A. This is k minus 2. Why it is? I should know A1 to get the A2. So now if I put here k is equal to 4, I can get the A2 here. It means that this coefficient A can be calculated from A, matrix A, where I can take the first column and a first row and column number 3 onwards. Now look here. What are the A? What are the A here? A was the delta cross y naught, delta square cross y naught, delta cube cross y naught. These are the value of A. Now, how can I get this value? I can get the value of delta cross y naught from this. I can get the value of delta cross y naught from here. I can get the value of delta cross cube y naught from here. Where it is located? It is located at the matrix A in the first row, right? It is in the first row, and I want to find out the value of delta cross y naught, delta cross square y naught, delta cross cube y naught. From where it is started? It is started from column number 3 onwards. Okay. Now, but if I want to write here, look here, our row is constant. There is no moving in the row, but it has to move k3, k4, k5, k6 like this, right? That's why, since I have defined the for loop here, k is equal to 4 to n plus 2. Therefore, this A, k minus 2 is equal to, it should be matrix A of the first row with k minus 1 column. K is equal to 4 means it is now A2. Okay, I can get here first row. This is the first row I can get, and column 3 onwards. Means I can pick up from this, I can pick up from this, I can pick up from this. It means that now if I do here programming here, now if I do programming here, what I can get here, for loop, k will move from 4 to n plus 2. This is the coefficient of delta cross y naught, delta cross square y naught, and delta cross cube y naught. This is coming from the table, right? So I have defined first row and third column onwards. Now let us define Cz. right? This is suppose again k minus 2. What is the formula of the Newton divided difference interpolation? The formula is, if I look here in the formula of this, y naught plus x minus x naught into delta cross y naught. What is x minus x naught? This is z, and delta cross y naught, which is defined by a. It means I can get the value of c k minus 2. I can get this is by, how can I get? I can get this is by multiplication of z k minus 2 into a k minus 2. Okay, then I can end this for loop. This is the main thing. This is the main thing we need to understand here. Now we have developed, this is the Matlab code we have developed here. And the previous we have developed an algorithm. This is the algorithm we have developed. How I can get the Z, how I can get the A, right? How I can get the C. Now this is the Matlab code we have developed, K move from 4 onwards. Let us try to write this logic in the Matlab language. Okay. Let us try to write, this is Matlab language here. Now look here, see, in the previous lab session, this was the program. This was the program we have developed. Okay, the program was that if I input the value of x, value of y, I can get all these things. Okay, now I displayed here up to this. And now let us try to add. Let us try to add our next up to this. See, from here, from this loop, what I can write here, I can modify it is like this. This was the program to construct the forward difference table. I can write here percentage, right? Loop for the construction of divided difference table. Okay, this was the loop we have constructed here, right? So here construction, next loop, I want to write here next percentage loop for the Newton divided difference interpolation formula. I'll start from here now. What is the loop now? 4 k is equal to 4 to n plus 2. Okay, just be careful. So what we have developed something I want to write here, right? Now z, before that what we did, before using the for loop, for the first case I have to, for the first time I have to define this one. Before defining this one, I have to define these things before for loop. Okay, before for loop I have to define, because we don't record any for loop there. It means that I will define z1 is equal to 1, okay, and c here 1 is equal to y1. Okay, we have defined it. Come up here. After coming here, for loop I have applied here. What was the for loop? Z bracket, it was k minus 2 is equal to bracket p minus x bracket k minus 3 bracket close. It was, I have to multiply with z bracket k minus 3 because k moved from 4. Okay, here. What is p now? Just look here. Thus, I want to remove now comment. Remove the comment. Okay. Input মানে enter the point to be interpolated. So I have to enter there. So look for the Newton divided difference interpolation formula. Z is equal to 1 is equal to 1. C is equal to 1 in this is the value of y I'll take here. Now next I have to define what is the value of this coefficients, right? It is defined by again k minus 2 here is equal to, okay, it was what we had defined here. This matrix A is this is the similar this matrix A. From the matrix A I took the first row comma then k minus 1 because we want the table from k3 onwards. Okay, now I can get here C k minus 2 is equal to Z k minus 2 into A k minus 2. Here I have put it here. Okay. Now I want to end here. See, look for Newton divided difference interpolation formula. Okay. So for the first term, I can write here. I can write here comments for first terms. For first term of Newton divided difference interpolation formula. Okay, and this loop is for second terms onwards for Newton divided difference interpolation formula. Why it is, just be careful here in our calculations. What was the formula of it? The formula was like this here. Just look the formula here. Just look the formula here. Newton divided difference formula here. Look here. The first term. This is the first term. Second terms onwards, we have applied the algorithm here. Okay. Now come off our final here. Our final look here. Now function I apply here, function f p is equal to divided underscore interpolation. Here you can write as per choice, right? Function f p is equal to divided underscore interpolation. So you can write here as per your choice. Divided underscore interpolation, you can write as per your choice. Inside the bracket, I want to input x, I want to input y, then I can get the value, interpolating value p. Okay, so x input, enter the value of x in the factor form, enter the value of y in the factor form, enter the point to be interpolated, length of the point, then here matrix which is null matrix. This is the matrix A where the first column will be value of x. This is the matrix A where the first column is value of x and second column is value of y. Okay, and from here up to this A, I don't want to discuss this one because we have already developed in the last session. Now here looping for the coefficients, right? This is for first term, right? This is for first term of Newton divided difference interpolation formula. Okay, and this for loop is percentage for second terms onwards, second term onwards of Newton divided difference interpolation formula. Okay, onwards will work here. Now 4, okay, up to this. Now I have to end here for loop. I have to end the for loop here. We have end the for loop here, right? Here we have ended our for loop. I have ended here for loop. Now what is the formula now? Suppose after ending here, FP means interpolating formula. How I can get? I have to sum. I have to sum the C. What is the C? C is the multiplication of Z and A. So I have to sum C. Why should I sum C here? Let's look here. Newton divided difference interpolation. It has been observed that first term, second term is Z into A, Z into A. Finally, I have to sum up. If I multiply Z into A, this is C. Z into A, this is C. Z into A, this is C. Finally, for the Newton divided difference interpolations, I have to add first term, second term, third term up to n term. So I have to end this one, right? I have to end here after sum. And here finally I can get here n, because at the beginning of the program I have to use the function, right? After the sum I have to apply the function. Look here, function fp, right? Fp, that's why at the last result will be fp. Fp is equal to sum c. What is the c? This is the product of a and z, and I can get here finally. Okay. Now if I am trying to run this program, let us try to run this program, right? I hope you have understood how we have developed these tables and this. Just try to run this program now. Okay, try to run this program. Okay, now enter the value of x in vector form. Okay, now if I want to run this is suppose let us take the value of x. Value of x is suppose 4, 5 this. Okay, enter the, we have input the value of x is 4, 5, 7, 10. Let us take the help of from the books where I can get a solved problem here. Okay, now enter the value of y now, which is 4800 written here. Okay, okay, enter the value of interpolated, right? Means suppose here in the book they're asking for 8. We input here 8. So if I run here, see what I can get here. First the matrix, see, null matrix, then the value of x, value of x, value of y has been printed here. Next I can get this is divided difference table. This column 7 will become here, right? So this is the divided difference table in the upper triangular form. Now this is the value of c. Value of c means what? For the first term of the divided difference interpolation, this is the value of c. It is 48. It is correct or not? How can I cross check it? It is very simple. How it is coming? This is the first value of y, 48. Okay, now answer is 448. In the book also this coming 448. Okay, let us try to run same data by taking other points. For example, if this value of this, I have run it. Now come up here again, take the value of this again. Let's take 15 here. Answer is coming 3150. In the book also 3150. It means that our algorithm is working very accurately here. Okay, up to this A, this is the divided difference table. Today lecture is more importantly for looping system for the coefficient first term of Newton divided difference interpolation formula. So we defined for the first term, from second term onwards we have defined it. Okay, let us try to run for another set of points. Try to run here other set of points where I can take 5, 7, 11, 13. 5, 7, 11, 13. Yeah. No, this is no. Let us take 13. No, let's take other values. Yes, 5, 7, 11, 13, 17. Okay, take it. Take the value of this. Value is 150, 392. 150, 392. Take it. Yes, I took this one. And they're asking for at what? At the point 9. They're asking for at 9. If I move here, see, answer is 810. In the book also it is 810. Let us try to understand this one, right? So matrix, null matrix, we have insert the value of x, value of x, value of y, and we can get this is the divided difference table in the upper triangular form. Okay, value of c means value of y first, so answer is coming 810. It means that we have developed one Matlab code where we can do the Newton divided difference interpolations formula here, right? And now just relook this one function. We are applying the functions AP divided underscore interpolations. It has been run very carefully. Then we have cross-checked that the answer is coming very perfectly. Now I hope you have understood the algorithms we have developed here, right? Please don't try to memorize the algorithm, whatever we have developed here. Okay, so today we have mainly two purposes we have. The first purpose was that our first objective was that to develop an algorithm for the Newton divided difference interpolation formula. Our second objective was that to develop a Matlab code for the Newton divided difference interpolation formula. Now we have found that the algorithms in the Matlab code are running smoothly, and we have cross-checked by taking various number of data here, and it has been found that the program is run smoothly. So we can conclude that our code is working perfectly. Now be careful that if you try to memorize that code, whatever we did here, then you are not able to do that. Because if I look in different prospect, whatever I have used here, looping system, maybe number of row and number of columns or number of terms, it has been here developed according to our prospect, whatever we had planned. The same interpolation technique can be coded in the Matlab in different prospects. So don't confuse from looking here and there. Just keep your mind that we have developed divided difference table. Accordingly, we apply it to get the interpolation value. I hope you have understood today's lab sessions. Okay, so today I'll stop here, and next class, what we'll do that in the next class, what we'll do that we'll again do for the interpolation technique for the Lagrange's interpolation formula. My request is that please don't try to memorize any of the code. If you try to memorize it, you cannot do that. Okay, thank you very much. Today we'll stop here.